So this is the second part of the lesson on ellipses and hyperbolas. So the second part of 10.5. Again, we've got a lot of definitions and things about hyperbolas. You're going to see a lot of similarities between hyperbolas and ellipses, but they're conic sections that are going to be pointing outward instead of inward. So they are a little bit different, obviously. So with hyperbolas, you've got this part. This is the actual hyperbola. So that's the hyperbola itself. And then these dashed lines that you see, they're not really there. Okay, it's kind of like when we have asymptotes. They're not really there, but they are. And so you've got this rectangular box that you draw lightly, but you need to draw it because it gives you a definition for where your asymptotes go. So as with other asymptotes we've seen, the graph approaches but doesn't touch it, and so that's what happens with these hyperbolas is we've got these asymptotes. The other thing you'll notice is that with hyperbolas, the foci are on the outside of it, but yet they're on the inside because if this is the hyperbola. So it's kind of like a hyperbola is like, a parabola, except there's two of them and they're facing opposite directions. If we had a parabola, like with a quadratic, and this is part that we didn't study this year, but a parabola does have a focus. It's like a satellite dish. And that thing that sticks up in the satellite dish, that is actually the point of focus. And so that's this point that's equidistant from each of the points on the parabola. My picture's not very good, but that's what that is. And so that is part of a parabola. We didn't put that into our study this year, but just so you know. So with a hyperbola, it's got a focus, two of them, foci. It's got a vertex. And so the vertex, there's actually two vertices, and it's right here and right here, okay? These are called, they're not vertices, but they're the points that give you what's called the conjugate axis. So that's like the minor axis. But the thing with hyperbola is it's not necessarily shorter. The transverse axis is the one where it has the vertices on it. So the vertex is on the transverse axis. Now, if you have hyperbolas that are opening up and down like that, then your transverse axis is going to go like that. And it may or may not be longer than the conjugate axis. And so that's something that's different about hyperbolas. Okay. Again, as with the ellipse, the foci is a constant as far as the difference. So, well, it's the difference instead of the sum. So if you take like the distance from here to here and take away the distance from here to here, it's going to be the same as the difference between that and that. So it's with differences, and that comes into play in how we find our focus. Okay, so that's going to come up later. Okay, so talking about the standard equation of a hyperbola. So if you look at this and compare it to an ellipse, what do you notice that's different? The thing that should stand out really quick to you is that it's a minus sign instead of a plus sign, and that is the telltale sign that you're looking at a hyperbola. It's always going to have a 1 right there. If it doesn't have a 1, then it's not in standard form. These will tell us about the vertices. This will tell us about the axes and where the foci are. And so we're going to use all of those things to tell us information about the hyperbola. Now, if it's going the other way where it has y squared minus x squared, that means that your hyperbola is going to be going like this. If it's x squared minus y squared, then it's going to be going like that. And so that's how you know which way it's opening. Okay. The transverse axis is the axis formed by the first term of the equation. So if it's on the y-axis or if it's on the x-axis. So that's telling us which way it's opening, and that's where the transverse axis is. The conjugate axis is the axis that's formed by the second term. So the second term will tell us about the conjugate axis. And the conjugate axis, again, like I said, it might be longer than the transverse axis in a hyperbola. So the transverse vertices, or the main vertices that we call them, are from the center plus or minus whatever A is. So if the center is at 0, 0, then you're going to add or subtract A. The conjugate vertices are not really vertices, but they're kind of like the edge of our rectangle, and they're going to be from the center plus or minus B. Okay, so in a hyperbola, so if you look at the standard equation of hyperbola, we notice like there's a minus sign there, and so to find the foci, we're going to do plus. Remember with the ellipse, it was the other way. There was a plus in the equation, and so for the foci, we did a squared minus b squared. So we're kind of a way to remember is just the opposite. So we're going to say a squared plus b squared equals c squared. So it is the Pythagorean Theorem. You're going to find c to find the foci. And so then there's how you would find the foci. And it's going to depend on which one's the transverse axis. So it might be c and then 0, or 0 and then c. or however the vertex is. The center of the hyperbola is the intersection of the transverse and conjugate axes. We'll see more about that when we graph them. It will make more sense. The asymptotes, again, are the line containing the diagonals of the rectangle determined by the axes. Okay, translations in hyperbolas, they're going to work the same way as they did in ellipses. Okay, we've got the H and the K, and are you moving it? Now, the thing you have to watch is if the Y is first, that's still the K. It's still going to be up or down translated, and the X is still going to be the left or right translation. So let's go ahead and graph these. You can refer back to all of these formulas, but I think after you graph a few, it's going to make a lot more sense. In fact, I know it will. Okay, so let's go ahead and take a look at some examples. So in your notes, we've got some examples 7 through 12, and so we're going to do those, and you can do as many of these as you want in your notes, or you can do all of them, whatever it takes for you to understand this. So there's some things that I'm going to ask you to do. I want to know the center of your hyperbola, the transverse and the conjugate vertices, so both of those points, and the foci, and then you're going to sketch the graph, including the asymptotes. So first thing we're going to do is we're going to notice that X is first. So that means that my transverse axis is going to be horizontal. Okay, so that's something I want to make sure I note. Since there's no translation, my center is going to be at 0, 0. So I'm going to write center is at 0, 0. Okay, now the next thing that I'm going to do is I need to worry about my transverse and my conjugate axis. So the transverse is going to be on my main axis, and it's going to be plus or minus 2. So I'm going to start at the center. I'm going to go 2 and 2 because that's a square root of 4. Okay, so as far as my transverse vertices, or my main vertices, I'll just put TV for transverse vertices, and that's going to be 2, 0 and negative 2, 0. You could put plus or minus 2, comma 0. Okay, for my conjugate vertices, I'm going to take the square root of 16, and I'm going to go vertically because they're with the y. So I'm going to go up 4 and down 4. And so I'm going to put conjugate vertices, and those are going to be 0, 4, and 0, negative 4. Okay, now the next thing I'm going to do is I'm going to make my rectangle. Okay, this rectangle that I make is going to kind of outline where my asymptotes are going to go and how the hyperbola is going to form. And so I'm just going to do that with dashed lines, and then get a straight edge. I can't have a straight edge on here, so I'll have to do the best I can. But you're going to get a straight edge, and you're going to draw for the diagonals and extend them. So it's going to be a diagonal through the center and through the corners of your rectangle. If you get a straight edge, it makes it a lot easier to do. Okay, like that. Now remember that at the very beginning, we noticed that the x-axis was going to be our transverse axis. And so what that means is it means my hyperbola is going to start right here, and it's going to go out towards the asymptotes in both directions, like that, and then same on the other side. So approaching but not touching, and that's your hyperbola. Now the last thing that I need to find is I need to find the foci. And so to find the foci, I'm going to say a squared plus b squared equals c squared. So that's 20 is equal to c squared. So plus or minus the square root of 20, which is plus or minus 2 square root 5. And so on my transverse axis, I'm going to go out 2 square root 5. And so if you find the decimal approximation for that, it's going to be 4.47. You'll notice that the foci is going to be past the vertices. It has to be. So about 4.5, and at negative about 4.5. So that's my foci. So label those as your foci. These are your vertices right there. You do not have to label the conjugate vertices. So just put a V next to your vertices and F by the foci, and that's a complete graph. Okay? So as far as your foci, you're going to say plus or minus 2 square root 5, comma 0, or you can do them separately. So that's how you graph a hyperbola. Okay, let's do another one. Okay, number 8. So again, on this one, we got to notice what's happening. And so the y is first here. So that means that it's going to be going that direction. That's how my hyperbola is going to go. And so I need to make note of that. So when I do my transverse vertices, they're going to be vertical. They're going to be like that. And so I need to make sure that that's in my mind so that I'm not getting it all mixed up. Okay. So my center is going to be at 0, 0 because h is 0 and k is 0. So my center is at 0, 0. Okay, my transverse vertices are going to be square root of 9. So I'm going to go up 3 and I'm going to go down 3. So I'm going to have 0 plus or minus 3. Okay, for my conjugate vertices, wow, they're the exact same. And so one thing you'll notice about a hyperbola that you're not going to see an ellipse usually is that it can be a square. With an ellipse, if these two are the same, it would be a circle. And so we don't usually consider that an ellipse, we call it a circle, and we have like a whole special unit on that. So anyway, these are my conjugate vertices. So I'm going to label this as a vertex and this is a vertex. That's where my hyperbola is going to go out from when I get to that point. Right now what I'm going to do is I'm going to make my little rectangle. And then I'm going to draw my diagonals. And then I'm ready, well, let me label my vertices. So it's going to be plus or minus 3, 0. Okay. So now I'm going to draw my hyperbola. So I'm starting at the vertices and I'm going to go this direction. Now, a common mistake is that people just don't stop and pay attention to which way the hyperbola is going. And so they're drawing the hyperbola going like this, and that's not right. So you have to pay attention to that. Now your foci are going to be somewhere there. So I know that already. Okay, so I'm going to do a squared plus b squared equals c squared. So that's 18 equals c squared. So c is equal to the square root of 18, which is 3 square root 2, plus or minus. So get a decimal approximation for 3 square root 2. It's going to be 4.24. So I'm going to go up 4 and a little bit, and down 4 and a little bit, and that's going to be my foci. So my foci will be 0, comma, plus or minus 3 square root 2. And that's a completed graph. Okay, so what I want you to do is I want you to go to numbers 9 and 10, and I want you to choose at least one of them, but maybe you should try 2 of them, both 9 and 10, and I want you to graph them and see if you can get it right, and then turn the video back on, and I'll show you how to do them. Okay, for this one, noticing that y is first, it's going to be going like that, so I just have that in my head. So my center is at 0, 0. I am going to start there, and on my transverse axis, it's going to be square root of 16, so I'm going to go up 4 and down 4. My conjugate axis will be square root of 9, so that's going to be 3. I'm going to make my rectangle, and I'm going to make my diagonals. And then I'm going to draw my hyperbola. So since I already know that it's going to be going this direction, because that's in my head because I found that out first, I'm not going to get that wrong. I also know my foci then will be there, so that helps me when I go to draw it. I can make sure I pay attention. Let's do our transverse vertices. That's going to be at 0 plus or minus 4. My conjugate vertices will be at 3 plus or minus 3, comma 0. Okay, my foci is going to be 16 plus 9 equals c squared, so that's 25 is equal to c squared, so c is equal to 5. So I'm going to go 0 plus or minus 5. So my foci will be right there and right there. So foci, vertex, okay, center, and that's my hyperbola. Okay, the next one, x is first, and so it's going to be opening this direction. So I find my center. My center is at 0, 0. I am going to use my transverse axis is going to go out 2. My conjugate axis will be up 5 and down 5. So this is an example where the conjugate axis is longer than the transverse axis. It's not like major and minor axis with an ellipse where the major is always bigger. So with a hyperbola, it's a little bit different. So this little box that I'm drawing, the rectangle, it helps me form my hyperbola, my asymptotes, and so it's really helpful. Like I said, it's not really there, but yet it is. And that's why you do it with dashed lines. The asymptotes do need to be drawn. That's absolutely, you're going to draw them, but you do it with dotted lines because that's how we do asymptotes. So my transverse vertices are plus or minus 2, 0. My conjugate vertices are going to be 0 plus or minus 5. my foci is going to be 4 plus 25 equals c squared. So c is equal to plus or minus square root 29. So square root 29 is about 5.4. And so I'm going to come out here to 5.4. And 5.4, and that's my foci. So back to what a foci is. If you pick any point on the hyperbola, so let's just say I pick this point P, if I take how far it is to that foci and how far it is to that foci and subtract them, that's going to be exactly the same as if I pick some other point. What's the difference between that distance and that distance? The difference between them will be the same. And so I'll see if I can find some videos and link it on Canvas so you can kind of see how that works, but that's something that I'll have to check into. Oh, whoops, that's not right. Okay, so the foci is going to be plus or minus the square root of 29, 0. Okay, for our last two, we're going to be seeing a translation. Let's actually go to number 12 first, and then I'll come back to number 11. So for number 12, I noticed that x is first, so it means that my hyperbola is going to be going like that. I can see that it's going to be shifted right 1, and it's going to be up 0. So my center will be at positive 1, 0. Okay, my center is at 1, 0. So then, as with other things that we've translated with, like with the ellipses and circles and things like that, that point is now my center. Okay, so from that point, I'm going to go my transverse axis. I'll go 4 away from that. So I'm going to go 1, 2, 3, 4, and then 1, 2, 3, 4. So my transverse vertices are going to be at 5, 0, and negative 3, 0. So you got to be careful with, if it's translated, you have to be careful about writing out your vertices. My conjugate vertices will be 5 away from the center, so I'm going to go up 5 and down 5. And when I write my conjugate vertices, it's going to be 1, 5, and 1, negative 5. Okay, my foci is going to be 16 plus 25 equals c squared. And so that's going to be 41 is equal to c squared. So c is equal to square root of 41. So what I have to do, I'm going to get a decimal approximation for square root of 41, which is 6.4 or so. And so from the center, which is that, I'm going to go out 6.4 on my main axis. So 1, 2, 3, 4, 5, 6, and a little bit right there. And so back 1, 2, 3, 4, 5, 6, and a little bit right there. Okay, so the thing that I have to do when I write my ordered pairs is I'm going to have to use plus and minus signs. So I'm going to say, I'm going to start at 1 and I'm going to add square root of 41 and I'm going to go up 0. And I'm going to start at 1 and I'm going to subtract square root of 41, 0. So when you're doing the foci on something like that, when it's translated, you have to really pay attention to where your center is and where you're starting. Okay, so I'll go back and finish the rest of the hyperbola. And so like I said before, it's really good idea to, at the very beginning of the problem, make sure you kind of fix it in your mind which way things are opening, okay, which way is the hyperbola going, so you don't get that mixed up, because that's one of the most common mistakes. Okay, so, and on your test, I'll be asking you to label all of these points. So the center, vertex, vertex, and foci. Okay, and then I'll want to see your asymptotes, and I'll want to see that, you know, the conjugate vertices and all of that. So be prepared for that. Let's go back to number 11. This one, I'm going to notice, first of all, that y is first. And with an ellipse, it didn't matter if y was first or x was first, because when you're adding, it's commutative, so it doesn't matter. But because you're subtracting, it does matter which one's first, and that's why it really makes a difference here with the transverse and conjugate axes. So since y is first, my hyperbola is going to be going that direction. And if it helps you to sketch it like that, just to kind of fix it in your mind, go for it. Okay, now this one is going to go right 1, and the reason why it's going right 1 is because that's with the x. This red one right here, it's going to be going down 1, because that's with the y. So I'm going to start at 0, and I'm going to go to the right 1 and down 1, and that is my center right there. So my center is 1, negative 1. Okay, from there, I'm going to go for my transverse axis. I'm going to go square root of 9, which is 3. That's on the y. So I'm going to go up 1, 2, 3, and down 1, 2, 3. So that's where my hyperbola is going to start. It's going to go like that. Okay, so I'm not ready to sketch it yet, but that's how it's going to go. My conjugate vertex is going to go over 4. Okay, so my conjugate vertex is going to be starting at 1, and we're going to go plus, wait, hold on, 1 plus 4, I do know that one, it's 5, and then down 1. And then 1 minus 4 is going to be at negative 3, and then down 1. So don't write 1 plus 4 because you know what that is. And the transverse vertices are going to be at 1, comma, and then it's going to be negative 1 plus 3. But again, I know what negative 1 plus 3 is, and there's no approximating or anything like that. So it's going to be at 2, and then 1, negative 4. Okay, so if you have it on the graph, obviously you can see that. It's just when you have square roots that you're going to write like 1 plus square root 29 or something like that. If you have integers, you're going to tell me what that is. Okay, I'm going to go ahead and draw my rectangle and my asymptotes. Like I said, a straight edge is really helpful there. And I already know that my hyperbola is going to be opening up and down, so that's important not to forget here. I'm going to be opening like this. Ideally, this would be in one smooth motion, but it's really hard to draw like that. I guess that's not bad. Okay, for my foci, I'm going to say 9 plus 16. So I've seen that number before. It's 25, so C is equal to 5. So on my transverse axis, I'm going to start at the center. I'm going to go up 1, 2, 3, 4, 5, and down 5. So my foci is going to be at 1, and then at negative 1 plus 5, so 4, and negative 1 minus 5, which is negative 6. Okay, so those are plenty of examples for you to see how to graph hyperbolas. Like I said, I'll try to find a video to link for you showing about the foci, but you're going to do your practice now, your homework with graphing ellipses and hyperbolas.